Right. Now we are looking at triploblastic animals. All right. These are nice. They're going to be very fun. We've seen the diploblastic. We saw that it was only cnidarians. We talked about them. And now we want to see triploblastic and see their natures and see everything about them. Now, these triploblastic animals are not as simple as just, saying they look like this. What we know about them is that they have three layers, right? They have three layers. Exactly. That is something basic about them. But then they are going to be divided. They themselves are going to be divided into other parts. We'll see how just now. So first, let's look at what these generally are. So triploblastic, we know they're going to have three layers. Tri means three, right? And we know that they are the six that we haven't talked about so far. We've talked about peripheral, and we've said that peripheral is out because it doesn't have true tissues, so it can't have germ layers, right? Then we saw that cnidarians have two germ layers, and that means that they are diploblastic, okay? So they don't qualify in triploblastic, guys. Now the remaining six, which is arthropoda, you should know them. Let's put the Latin names: arthropoda, and then chordata, okay, which is us, right? Chordata, these are the chordates, and these are the only vertebrates, okay? And they are the five guys: fish, mammals, birds, amphibians, and reptiles, right? Those are the chordates, which are the vertebrates, things with vertebrates. And then that's the only phylum with vertebrates. The others are invertebrate. So we have arthropoda, we have chordata. What else? We have echinodermata, okay? Echinodermata. We have say annelida. We have annelida, which makes them four, two to go. Then we have nematoda, okay? And then we have platyhelminthes. Platyhelminthes. All right, good. Now, if I can say something about this whilst we go, these annelida, nematoda, platyhelminthes, these three are worms, okay? Annelida, these are annelids, they are worms. Nematoda are worms as well. Platyhelminthes are worms as well. So platyhelminthes, these are flatworms, okay? These are the flatworms, like earthworms, right? And then nematoda, these are your roundworms. So I'm going to write here, these are your roundworms. So what is important to know is that platyhelminthes, these are flatworms. They don't have segments, they're just flat. And then nematoda or nematodes, these are roundworms. They don't have segments as well. Annelida or annelids are segmented worms, okay? These ones have segments. Like whatever it looks like is going to have segments. So these ones have segments. They could be flat, they could be round, but they should have segments. Mostly round with segments. Okay, so as long as you have a worm with a segment, then it is an annelid. Okay, it forms an annelid. So anyway, these are worms. We'll talk about them more. But all these six are triploblastic. Don't forget that all these six are going to be triploblastic, and we are going to organize them. They have, in their gastrular stage of the embryonic development cycle, they will have three layers of cells. Remember gastrula, we talked about blastula, we've talked about the gastrula. Gastrula is when the bowl of cells now has layers. After gastrulation, it's now having layers. And now we say that this will have three. These guys will have three. So let's see. What are the three? The three primary layers are those three that we've talked about, the three layers themselves, which is endoderm, mesoderm, and ectoderm. Endo, the most inside one, meso, the middle one, and ectoderm, the outermost one. Now, I'm going to give you a basic diagram because we have three types of triploblastic layers. Three types of triploblastic. They will have all three types will have three layers, but the three layers will be arranged differently. Okay, we'll talk about them. Here is the simplest type, which just helps you to see the three guys. Remember, if you look at the diagram, it may look like there are four layers, but remember that the most inside is not a layer, it's the gut. Okay, it's an opening, it's the gut. And the gut lining, the wall of the gut, is the first layer, which is our endoderm, right? The most inside one. And then the middle one would be our mesoderm, right? And then the outermost layer will be our ectoderm, okay? So here we have our 3 layers. Can you see them? I hope you can. So here, these are the things. Now, they don't always look like this. They will be more complex ones. Let's see. This is the easiest type of the 3 guys. So triploblastic have 3 layers, and there are 3 types of triploblastic guys. Let's go through animals. So here, that is what it's saying. Here's the statement which says there are 3 types of triploblastic animals. We want to get to know them. But for us to understand them, first we must know about something called a coelom. Okay, coelom, when you spell it, it's actually Coelom. So we say coelom. Coelom. But when we pronounce it, we say coelom. Okay? The O is a silent one. So it's coelom. So coelom is a what? What is the coelom? What is it? It's a fluid-filled body cavity. When we say cavity, we mean space. So it is a fluid-filled space that is completely, listen to this part, completely lined by tissue that comes from the mesoderm. Okay, so that means a true coelom, if something is a true coelom, it is a cavity, which means it's an opening that has fluid. Yes, fluid could be liquid or gas, right? So it's a fluid-filled body cavity, right? Which is completely lined, which means the walls of this coelom should be the mesoderm. Okay, it should be layers from the mesoderm. That is the true coelom. So, it's a space, and it's seen from the embryonic stage, from the gastrular stage of the embryo. You can see the coelom. Okay, when something becomes an adult as well, the coelom is still there. So it's seen from the embryo itself. We saw the embryo where it comes from. It comes from the zygote, which is the fertilized egg. And we said embryo, it is what is then made from the zygote. When it goes through, first it's fertilization, it becomes a zygote. Then it starts dividing by mitosis. It becomes an embryo. When it's now a ball of cells, more than one cell, because a zygote is one cell that is made by the sperm and the egg together form one cell called a zygote, which now divides by mitosis, forms the embryo. Embryo starts going through stages, and that is what we call embryonic development. Embryo growing, it goes through the first where it's just a ball of cells with water inside, right? And now it keeps going. It becomes a gastrula now. When it's just a ball of cells, it's called a blastula, okay? With something called a blastocyst, which is the water inside. Then it becomes a gastrula when it now has a ball of cells with 3 different layers or 2 layers. It could have 2 or 3, as we've seen. Animals can have 2 or 3. Now we are talking about having 3 layers. And we said, when we are talking about it having 3 layers, we must know that there is something else that can be found in those 3 layers. And it's a gap that is found in those 3 layers. You can see some space which has nothing but fluid, which could be a liquid or a gas. And that space is called the coelom. Okay, coelom is a fluid-filled body cavity. It's a body cavity, which means space. When we say cavity, it's space. Now, and what is the function of this guy? I'm going to skip this statement because it repeats with what is listed just below. What is the function of this coelom? Now, coelom has 4 functions, though 3 are so important, you could get them asked. What are the functions or the benefits, okay, or functions and benefits of this coelom? Number 1, it provides space for the organs to grow independently of the wall. It gives you space. We know that coelom is a space. So what good does this space do? It allows the body organs to grow away from the wall, independent of the wall. So they can grow inside without the wall having to grow with them. They can grow and this allows the body organs to be big and well and complex. Look at this. Here is the coelom. Can you see this space I'm shading in blue? This is the coelom. You can see it in the body. This space, it is fluid, whether it's liquid or it's gas, we don't care. But there is a fluid in there. And that is where these organs are hanging in. We know that this coelom was there when it was still an embryo. Now we can see it all the way when it's an adult. So the reason why we've got this nice, big, complicated guy here is because the coelom allowed it. He allowed this to grow and allowed this to grow, this other part to grow, and allowed this other part to grow independent of this wall outside, okay? Away from the wall. It wasn't stuck to the wall. It's not stuck to the wall. These organs are not stuck to the wall. They are hanging in the coelom. So now they can start to grow in that coelom because the coelom gives them space to grow. That is why they've grown to be this big. If there was a wall, the wall would stop them. But coelom gives them space to grow. So that means it allows for complex body organs to be developed. How? By providing space for these organs to grow independent of the wall. It gives them space for the organs to grow, because organs will be coming from the germ cells, the germ layers that we talked about. What is the other function of the coelom here? Cushioning and shock absorption, right? So sometimes your body goes through mechanical forces. These are things that hit, right? These are things that actually hit. They are called mechanical forces. Now, the coelom, this fluid-filled body cavity, protects these guys, these inner guys, from feeling the pain. It doesn't arrive. The force does not arrive as strong as it was. It gives a cushion. It's like a cushion. So it's not as hard, right? That is the other function. It protects them by surrounding them with a liquid or fluid, right? So that means that when something hits the outside of the body, the force, when it hits here, the force, some of it is absorbed by this fluid, and it doesn't arrive to the organs being as big as it was. Okay? It will still arrive, but not as much as it would have been. That's the other function of the coelom. All right. Now the third is saying it gives circulation. When we say circulation, what we're just saying is that this coelom, this cavity, in some animals, it helps in distributing nutrients around the body, and also in the removal of waste around the body. So it helps in circulation, the circulatory system, taking in nutrients to other parts, okay? Because some nutrients may want to get to these body organs that are in it. It could help as well. And also removing the waste that could be released by organs that are hanging in the coelom. It could help move that waste out of the body. Great. So the coelom is very helpful. Now, the last thing that we could have this coelom do is this one, hydrostatic skeleton. Hydrostatic skeleton. What do we mean by hydrostatic skeleton? Now, we have some soft animals, right? These soft animals don't have a skeleton like us. These bones. We have some animals that don't have bones. And these animals that don't have bones still need a skeleton, because a skeleton is something that helps you to maintain your shape. So this coelom, this cavity that is filled with fluid, it's not just empty space. This space has air or water, right? So let's just say liquid or gas, right? So now this fluid-filled cavity, which is a cavity that is a liquid or gas, it helps these animals to maintain their shape and also to move, okay? Because the skeleton also helps us to move. So they have a hydrostatic skeleton, which is a skeleton made from the fluid. And that is your coelom. It can act as a skeleton to some of those soft animals, right? That don't have rigid structures, that don't have bones like us. Hope it makes sense, right? And that's the other function of a coelom. Now, we've seen the benefits. We've explained what a coelom is. Let's see how we can see it and how it makes the three different parts, the three different versions of triploblastic animals, right? Let's go through them. So we want to see those three different versions. I think I'm going to stop the video here. Then we'll talk about the three different versions in the next video. Goodbye for now.